All right, honor students, let's get into the first standard, and this is going to be W1, simple harmonic motion. In this standard, we're going to look at primarily period and frequency. Before we can even get to period and frequency, I want to talk to you about what an oscillation is. Definition-wise, an oscillation is the periodic varying of a system or a position of a system about a point. Basically what it means is that an object that's going back and forth about one central location is oscillating. One example in oscillation, a lot of times what I think about is that if you had, say, like a piece of wood that's floating on the surface of the water, if you were to push first the piece of wood still in the water, if you were to push down onto that piece of wood and push it below the surface, that piece of wood would bob up and down on the surface, right? It would go above where it originally was and below where it was originally, back and forth, back and forth. That is an oscillating object. Anything that is repeating its position about some central point is oscillating. In our talk about waves, everything starts with understanding what an oscillation is. One important thing to understand about oscillations is every system that is oscillating contains energy within it. That's the thing that's happening. When you pushed on that piece of wood bobbing in the water, you added energy to it. The reason it's bobbing up and down is that piece of wood, that system is trying to expel its energy. It's not able to do so, and this is what the oscillation is. Another example of an oscillating system is something that you're familiar with, and that is a pendulum. We just did the pendulum activity in class. Here you can see an example of a pendulum. The oscillation is happening about what in this term is equilibrium point. We're going to talk about that a little bit later. And it goes from one side to the next side, back and forth. That is an oscillation. All our talks about waves are going to start with this central idea that you have some energy added to some system, some sort of set of matter, and that system is repeating its position back and forth and oscillating. The next thing I want to talk about is I want to talk about period and frequency. Any system that's oscillating can be described in terms of its timing by period and frequency. The term period, which is given by the symbol capital T, that is the time it takes to complete one oscillation. Period is measured in seconds. So we want to say how long it took, we just say it took X amount of seconds. When we talk about frequency, frequency is the number of oscillations that occur in 1 unit of time. And that 1 unit of time is a second. So if we want to say what the frequency of an object is, it's how many oscillations happen in 1 second. The unit for oscillation is hertz, and you've probably heard of the term hertz before. Hertz is just shorthand for 1/seconds. So we give frequency in hertz. If I said something, for example, had 7 hertz, what that means is that that's occurring 7 times per second. Now, period and frequency are related to one another. The relationship between period and frequency is that they are inverses of one another. Mathematically, we see this by this equation. We see that frequency, which is given by the cursive looking F, frequency is equal to 1/period. Conversely, you could say that period is equal to 1/frequency. I asked you to have your reference tables out here. If you look in your reference tables on page 5, within your reference tables, you'll see this relationship on page 5 in your reference tables showing you that period and frequency are inverses of one another. And a lot of what we're going to do today in this lesson is just going to look at that relationship between period and frequency. How do we calculate them from another, and how do we calculate them just from a description of a system? So let's go ahead and do that, and you should see some examples of this in your notes underneath the page we just talked about. So let's look at that very first example. It says, what is the frequency if you have a system that undergoes 3 oscillations in 1 second? So 3 oscillations per second. Let's talk about what frequency is. We said that frequency was the number of oscillations that happen in a certain amount of time, oscillations per second. Here they say we have an equation. This is not in your reference table, but the whole definition of frequency is identifying how many times something happens, a periodic oscillation happens in a period of time. In this example, they say that there's 3 oscillations in 1 second. So if we were to mathematically calculate what the frequency is, we would say that 3 oscillations per second is what we're looking at. And then we can see that the answer to this would be 3 hertz. That would be the response. 3 hertz just means it's happening 3 times per second. This should make a lot of sense. It wasn't a super difficult question, But let's take this one step further. This is not in your notes, but I do want to ask about this. If we find out that the frequency is 3 hertz, what about the period? Can we calculate the period from frequency? We know that period and frequency are inverse functions of one another, so that if you have period or you have frequency, you could find the other. In your reference tables, they say period is 1 over frequency. Symbolically, that looks like T, or the capital T, is equal to 1 over F. 1 frequency is 3 hertz, so 1 divided by 3 hertz will give you 0.33 seconds. Period is always given in time in seconds. This should sort of make sense in the first place. If you think about 3 oscillations per second, this thing's happening 3 times every second. How long does it take each thing to happen? 3 in a second. Each one takes 1/3 of a second, or 0.33 seconds. So not only from a mathematical point of view, we can see that the inverse works out, but also if we just think about it, just kind of keeping our wits about us, we can figure out that also the period would be 0.33 seconds in this example. Let's try another example. This one's also in your notes. And in this example, it says, what is the period of a bumblebee's wings if it flaps its wings 130 times every 3 seconds? Now here we're not giving it such clean numbers. We're not doing it per second. They're saying that this is happening 130 times every 3 seconds. We want period, and that is time. So period is going to be how much time has elapsed divided by how many oscillations that would happen. If you divide the time that has elapsed and then you divide it by the number of oscillations, you will find out how much time has occurred for each oscillation, right? That is what period is by definition. So looking at this, let's plug that in. Our time here is 3 seconds, and the number of oscillations is 130 oscillations. So if we do 3 divided by 130, we end up figuring out that here we have 0.023 seconds per oscillation. So if you want to know from this bumblebee who flaps its wings 130 times every 3 seconds, how long it took to just do 1 flap of its wings, that is 0.023 seconds. That is the period of its flapping of the wings. If we did the same thing we did with our previous example, having determined the period, let's now determine what the frequency of the bee's flapping of the wings. Remember, the frequency is just how many times it flaps its wings per second. It's going to be given in hertz. Period and frequency are inverse functions of each other. So if you have period, which we do, right, now we can figure out what the frequency is. Frequency is 1 over period. That would be 1 over 0.023 seconds. 0.23 seconds is the number of, or is how much time it takes it to flap its wing 1 time. So to figure out how many times it flaps its wings in 1 second, we just take the inverse. 1 divided by 0.023 seconds is 43 hertz. What that basically means is that this bumblebee is flapping its wings 43 times every second. It would be 43 1/3, but we're using significant figures, so we're not going to go on perpetually any ways in there. So the frequency here is 43 hertz. On the next slide in your Nearpod, you're going to find a question that's just going to ask you a couple questions about period and frequency to see how well you actually grasp the idea of determining period and frequency. So complete those slides, those questions. I will check that when I get a chance, and then go on to the next slide where we'll start talking about amplitude and equilibrium and eventually get to pendulums.